Hey there. So here's the last little bit of the notes on relative dating that we didn't get to yesterday that you need to have for what you're working on today. This picture's on the bottom of the back side of the notes, and obviously mine has some stuff that yours doesn't have. So let's talk about what that is, and then we'll talk about the order these go in. So first of all, I put a little tree and a little person up here at the top to represent the fact that that is the surface, just to make that clear in the picture. These first four layers right here are a nice demonstration of the law of superposition, because you can see that you've got them in those nice horizontal layers, and the ones on the bottom are older than the ones on the top. Down here, we're kind of looking at a little bit of that principle of original horizontality. These layers, Q, O, N, M, and L, are tilted in an angle, but they were originally laid down horizontally. So they originally started off horizontally like that. They got built up, and then something happened that caused them to tip, for example, two continental plates colliding. P right here is a great example of a cross-cutting relationship. So you have some kind of igneous intrusion in this particular example that cut through those 5 layers, and obviously it had to cut through them after they were already there, because if they weren't already there, there was nothing for it to cut through. Over here in layer M, you see these kind of chunks of things that are different colors than layer M. Those are examples of inclusions. So those are pieces of other rocks that were already in existence that got included into layer M when layer M was formed. Right here between layers K and J, you see this kind of wavy line, and you see another wavy line down here between H and the layers below it. Those wavy lines represent places where erosion has occurred, so that's an example of an unconformity. So those are some of the different principles we talked about demonstrated in this one picture. Now we need to put all that together and figure out the order that these rock layers were formed in. So over on the side, you've got a blank spot where you can fill this in from youngest to oldest. You can see I've already got it filled in. I'm going to talk you through how this came about. Starting down here, Q is the lowest layer, which means that Q is the oldest one. Up above that would be O, N, M, and L in that order. So Q being oldest and L being youngest of this set here, because according to that idea of original horizontality, they started out like this, and then according to the law of superposition, the ones on top would be younger and the ones on the bottom would be older. So that takes care of those layers. Then P, that crosscut, cuts through Q, O, N, M, and L. That means that it was formed after those layers already existed. They had to be there in order for that to cut through them. So that makes L, and then P, as we're going up the side over here on our oldest to youngest. Okay? Now, we've got this top part. K is obviously the youngest layer because it's up at the top, so that was an easy one to knock off. J is underneath that, which makes it next. I is underneath that, and H is underneath that because they're in just one nice straight line because they haven't been tilted. So starting youngest to oldest, we have K as the youngest, then J, then I, then H, then P, then L, then M, then N, then O, and then Q. So that's what you should have written down over here. So that's an example of how you would use those different principles that we went over yesterday to figure out the order that these rock layers were formed in to kind of tell the story of their geologic timeline. What you're going to be working on next are a couple of worksheets where you're going to put these into practice. Good luck!